Let's spend some time looking at our quadratic polynomial and its picture, which turns out to be the parabola. Very important features. Some definitions. There's some subtle differences between these things. So the quadratic polynomial is simply that. It's a piece of algebra. ax squared plus bx plus c. You notice there is no equal sign in there or anything like that. That is just the polynomial. The quadratic function is then when we make it equal to some other pronumeral. It becomes a function now. So usually we'd see it as y equals. And then the quadratic equation is when we make it equal to a number. Usually we see it with 0, but I guess it doesn't have to be 0. Now, if a, so the coefficient of x squared is 1, we call it monic. So it becomes a monic quadratic. Coefficients, well, hopefully we know what that is. They're the a, b and c, so the numbers in front of the pronumerals. The indeterminate, you might not have heard that expression before. That's just a fancy way of saying the unknown, the x, because we don't know what it is. We can't determine. It's indeterminate. So it could be anything. The roots are the solutions to the equation, whereas the zeros are the x-intercepts of the quadratic function. Now they are of course the same numbers, but technically you have roots of the equation and you have zeros of the function. Question says, find the roots of x squared minus 1 equals 0. And all it's really saying is solve it. So, alright, we solve it, x squared's 1, x is plus or minus 1. We're graphing the quadratics, so our parabola. The key features we look for, there it is, the general one, y equals ax squared plus bx plus c. That equation tells us things. A, so the coefficient of x squared, tells us whether we have a happy parabola. That's when a is positive, because when you're positive, you're happy. And we call that concave up, or we have a sad parabola. And that's when a is less than 0, it's negative. When we're feeling negative, we're sad. It's concave down. That's what a tells us. Now b by itself doesn't tell us that much, so I'll skip b for now. Let's go to c. Just like in any polynomial, the constant number tells you the y-intercept. The zeros, or the roots, depending on whether you're talking about the equation or the function, well, they're the x-intercepts. So b by itself doesn't tell you stuff. B in this form now tells you something. So x equals minus b on 2a is the axis of symmetry of the parabola. Another way of finding the axis of symmetry, if you already worked out the x-intercept or the zeros, because of symmetry, it must be in the middle. So you could just average those, and that would give you the axis of symmetry as well. The vertex also always is on the axis of symmetry, so you know the x value, then you substitute back in and you can get the y value. The minimum or maximum value of the function, they ask you that question, it's just looking for the y value, it's not asking for the vertex. So if they say what is the maximum or minimum of this function, basically saying, well, how high up does it go, how far down does it go? So they just want the y value. Okay, let's do an example. Now again, I'm just going to write all this down to illustrate finding the features. A lot of this stuff, again, you would not necessarily write down. So x squared plus 8x plus 12, a is 1, is positive, so I know I've got a concave up parabola. C is 12, so I know the y-intercept is 12. Let's plot that in. Let's find those x-intercepts. We solve the equation. We get negative 6 and negative 2. Let's plot those. Axis of symmetry, right, minus b on 2a, we get negative 4, or of course I could just average what I just found with the zeros, also negative 4. I would not dot that in normally. I'm just using that as an illustration for the example. Okay, there's our axis of symmetry. The vertex is on that line, so let's substitute in, and we get, by a coincidence, it's also negative 4. Let's plot that point. That's pretty much enough information to draw our parabola. There we go. We have our parabola. We know the roots of our quadratic are 3 and 6. What is the quadratic? Bang, got it straight away. Now why have I got it straight away? You've got to think back to how we factorise quadratics, and we always say, hey, what multiplies together to give this, adds together to give this? Well, in this case we've got the answers already. So therefore, that constant must have been 6 times 3, because we would have said what multiplies together to give this, 6 and 3. And we would have said what adds together to give this, but we've got to be careful. It'll be the negative of that, because when we factorise, we would have had a factor that said x minus 3 equals 0, so x became plus 3. So it'll always be the negative of the sum. 6 and 3 is 9, negative of that's negative 9. So it's a quick way of just bang, there's our quadratic. I've got a constant out the front, because of course any multiple of that would still have the same solutions. Now where that's real handy is if we don't have rational roots. We have something like this, 3 plus root 2 and 3 minus root 2. Because the beautiful thing here, bang, I can go straight to it. Because multiply them together, I got difference of 2 squares. 9 minus 2 is 7. Add them together and the surds cancel. 3 and 3 is 6, but it'll be the negative of that. Negative 6. In this case, I haven't multiplied it by a because they told me it's monic. So x squared minus 6x plus 7. We know the roots, but this time they've told us the vertex as well. All right. So x squared minus 10x plus 16, because 8 and 2 is 16. Add them together and get 10, so it's negative 10. Could be a multiple. But now that I know a point that it goes through, I can work out that multiple. I just substitute in. So subbing in, we just got to solve this little equation. A is negative a third. So there is my quadratic. Y equals negative a third, x squared minus 10x plus 16. Now, you know, say I've said use Desmos for question 4. We're all familiar with Desmos. We have a great little graphing package that we can use to draw graphs and find features that we need. So my suggestion, yeah, for number 4, use Desmos to have a go with that one.